Well, hey, thanks everyone for joining us today. Really appreciate it. As was mentioned, my name's Anthony Barkley. I'm the Chief Strategy Officer with Veracode. We really do appreciate you all having us here today. If you're not familiar with Veracode, we've been around almost 20 years. We actually started in the application security testing space. If you're familiar with static application code testing, dynamic testing, software composition analysis. Those are the areas we're typically known for. That last area specific to this discussion tonight around software supply chain, and I'll add a few things in there from our perspective, but really looking forward to hearing more from our individual guests. Before we jump into that, one of the areas I'll talk a little bit about is around, kind of the move that we've seen and the move we've made are into risk management, really taking all of that data together to help organizations kind of understand where do they prioritize and focus and kind of take action within their businesses. And that'll be part of what we want to understand here. This has been an evolving challenge in the kind of secure supply chain space. Each organization tackles it slightly differently. They have slightly different challenges depending on what types of software they develop, what types of external tools they use. And so with that, I'm going to hand it off and let each individual just kind of explain a little bit about themselves and their background, and then we'll go into a few questions.
Great, thank you. Good evening, everyone. I am Bill Yeager. I am Chief Product Security Officer for Lenovo's Infrastructure Solutions Group. Also on the Black Hat Review Board, running the platform security track. Background, security for decades. Fascinating experiences, solving challenges big and small for companies you've never heard of to companies you've always hear about. We were talking kind of before we started about the security space and how fantastic it is because it's so dynamic. And I think you're going to hear a little bit about how dynamic it is as we talk about software supply chain security and the things that are new today, this week, this month, and what's going to come tomorrow. So, thank you.
Hi, you all know me, I think. My name is Don Elsner. I'm the conference director here for the ISSA, but I do have a real day job. This is a conference director doesn't pay anything, so I had to go out and get a real job. Currently, I'm a senior security advisor at SAS, a software company in Cary. I'm on the governance risk compliance audit team. It's actually part of the legal team, even though I'm not an attorney. I work with a bunch of attorneys. And so it's long career. It kind of ended up here. I do have over 20 plus years in the security field across several industries. And so I'm talking today as myself and don't represent SAS as a disclaimer.
All right, and Mike Garvin. I am new to the field. I've only been in this for about a day or two. I'm the Chief Information Security Officer for Jagger. If you've been around here for a while, you probably recognize the SyQuest name from years and years and years ago. But my journey had started in more of IT, so systems administration and networking, moving through GRC compliance, audit roles, doing customer consulting through cybersecurity. Was interim CISO over at Duke Health for a while. I've worked for Symantec Sun, which doesn't exist anymore, and a few other places before landing at Jagger. Jagger is, you think about that in terms of like an Amazon, but for businesses. So if I need to buy 1 million pounds of steel to produce cars, or if I need to buy 10,000 pipettes to do lab work, that's the place where folks go. We have about $3.1 trillion a year in e-commerce that flows through the platform. And I did not have gray and white hair until I got there. So
Only about 2 weeks ago. A day. All right, cool. Well, a couple of things I'll kind of start with, and for those of you that know this space and have kind of watched in the news and some of the crazy things going on, this could go back as far as 2020 or even farther back than that. But the biggest stories would be things like SolarWinds, if you're familiar with that. Quite a few others, Log4j, MoveIt. Like these were all the big stories about various attacks within the supply chain and how they affected not only software development itself, but the software that was then distributed out to the end users and how it affected them. And so recently, we've seen some other interesting stories. One that happened actually twice, Shai-Hulud and Shai-Hulud 2, the actual package managers that were being used to distribute open source software and how those were being leveraged within the various organizations and how quickly various types of issues then propagated, not only through that system, but then into other organizations. And so we'll talk a little bit about that as well and how these organizations are helping to manage that for their respective businesses. And so with that, the first question we'll slip into is, when a major supply chain incident hits the news, like how do you assess that within your environment and what are the first steps that you take? So I'll turn over to you first.
Sure. So if you look at it from an open source component, for example, a major project gets hit, a supplier gets hit, we've got a comprehensive database of all of the things that go into our products. So one of our first steps whenever something hits the headlines is to really query the database, figure out what exposure there might be and what products might be affected or which suppliers who provided products might be affected. So one of the key things, and you hear this a lot in terms of a security fundamental, is the idea of know your assets, have an inventory, whether it's network inventory, software inventory, SBOM. That's totally key. If you don't know what products are in your products, what components are in your products, you're already losing the battle. So that awareness is really the first step of understanding what your exposures are when some industry issue happens.
Okay, yeah, totally agree with you there on that. It's about the inventory, and so we have several teams. If you're talking, about the software that's in your products, you have to have the inventory to know what's in there and what the dependencies are. And you should have plan B, right? What happens if the vendor that's part of your code can't give you the patches or the updates that you need to put out a secure product out there? What's your plan B? Is there another supplier that you can get your code from? And so we have teams that are, the security teams, sometimes it's a one-man team, sometimes it's a whole team, depending upon how big your company is and what products you're making, that are constantly getting the updates from the open source, or from the government regarding vulnerabilities, and they're tracking all that on a regular basis to see how it impacts your company or your products if you're developing something.
Yeah, I mean, the dirty secret that everyone learns eventually is that unfortunately asset management is a huge portion of the job. It's absolutely unglamorous and it winds up being one of the most important things you can possibly do. Another approach is a little bit more towards locking things down. So instead of pulling live packages, live dependencies, you could also consider a strategy where you're pulling them down on a regular basis. So you're doing a git clone, for example, of a project or a repo, and running off of those kinds of, slightly outdated. So you always have the option of saying, well, that got introduced in, version 2. I'm still on version 1 point whatever, so I know that my code base is secure. But, you have to look at that in terms of a business trade-off, right? There's trade-offs in terms of whether or not I'm using the latest and best components in my software. And then there's also trade-offs that there may be other vulnerabilities or other issues with that code because of the age, where a newer version might afford you, higher code quality or something like that. So, there's some trade-offs, and you have to look at your strategy in terms of how you want your developers to operate and really what your risk threshold is. And if it's sufficiently low, there are alternate plans you can put in place.
Yep. No, all very sound. And I would mention, as the vendor in the group here, one of the things we do with a lot of our customers is spend time understanding where they're at on that asset journey, what types of tools they've got, both for generating SBOMs, understanding what's within their software or the software they consume, or leveraging firewalls instead of bringing new repos, being able to use policy to say what can or can't be brought within my organization. It's not all perfect, but it does have to be integrated within your process. There's no just flip a switch and it just works. Well, let's, with that in mind, transition a little bit into kind of SDLC and governance. So within your respective organizations, who actually owns supply chain security? Is that engineering? Is it security? Is it legal and compliance, or a combination of all of those? And I'll start on the other end with Mike, and we'll work back.
It depends on who you ask. You're certain of your executives are going to wind up having the red shirt and beaming down to the planet first. But it is a shared responsibility. I try to look at the mantra of trust but verify. You want to have the right policies and procedures in place with all of your stakeholders. Your engineers, product management, development, legal, who is interested in whether or not you're using software that might have an intellectual property rights issue. And then my job outside of providing the secure software development lifecycle policies and procedures in coordination with, in our case, a product security working group, which cuts across the different engineering and software lines, is really saying, okay, I want to make sure that you're following those things, right? I trust that you're doing things correctly, that you're coding against the OWASP standards, whatever you happen to pick. But I want to follow up behind that with static analysis, software composition analysis, AI assistance on looking at the code that's going through. And identifying those issues as quickly as possible, because the worst thing I want to have happen is you're up against a production release, and all of a sudden you walk into the room and say, hey, I can't let you release that code or that particular feature. You really want to make sure that you're pushing that as far, I hate to say this is going to sound cliche, but pushing it as far left as possible so that you're identifying those code issues and taking care of them before you suddenly become the squeaky wheel in the organization.
Yeah, right on. I think it's everybody, like Michael said, it involves several of the different teams within your organization. And myself being on the legal team, I take more emphasis on the legal side of things. As Mike pointed out, intellectual property is big. I've run across developers in my past that just because it's open source, they think they're free to insert it into your source code, and don't realize that there's all kinds of licensing restrictions. A lot of times it is free for public consumption, but as soon as somebody else starts making money off of it, they want their cut. And you better be paying for them because they're going to find out about it sooner or later. And the other thing I'll say from the legal perspective is that you want very strict contract terms with anybody you deal with. So what happens if one of your vendors does have malware or starts sending you malware and you don't realize it, and it starts breaking some of your customers? You're now liable, but so you could even terminate your business model, right? So is there constraints or is there remuneration from your supply chain and there's contractual clauses that if they supply us with faulty software, are we going to be compensated for that because we're losing revenue because we've lost our whole customer base?
Shared responsibility, it's a team sport, right? So legal, absolutely a partner. Legal draws the contracts, approves them, depending on what you're talking about. The procurement organization, they're the ones buying things for your company, whether it's supply or for your own use. Security from a governance and actually validating that trust but verify, does it work or doesn't. And then fundamentally the development organization, engineering, they're the ones who are actually building the products. So everyone else can think everything's fine, but if you've got a developer who is coloring outside of the lines and putting things into your products without the other processes in place, you've got a problem. So everybody needs to be aligned and work together as a team in order to actually build those good, strong supply chain security practices that let us rely on the products we've got. It's kind of fascinating because when you look at these things, development always wants to go and adopt the shiny new whatever. Until there's a problem or until a customer questions it or until there's a headline, and then suddenly it's I didn't do it. So those sorts of experiences, especially accrued over time, really helps to build that team approach mentality, kind of the culture change, and that's really a good thing. It's hard to drive when you're starting out, but over time, the shared experiences really do build that we're all in this together approach. So from a supply chain security side, it's the shared responsibility, but it's also those scars, those wounds of those learned experiences that get everybody on board for kind of that shared mission. And that's what makes it successful.
Yeah, no, absolutely. Mike, you made a comment that I thought was interesting talking about AI, right? Like we all hear about AI. You can't listen to a TV show, a commercial, have a conversation where it doesn't come up. And we see it from both the offensive and the defensive perspective, right? A lot of our customers are trying to understand, like, how do we leverage AI not to just run a scan for static analysis, but take a look at my entire code base and tell me, are there fixes you can recommend that we consider, and can you automate that? And that's powerful if you can get that right, but that requires a tremendous amount of context to do well. Whether we're talking code or libraries that get brought in, third party, open source that can be part of this supply chain challenge. On the other side of that, obviously attackers are going to leverage this in every opportunity they can. And that's the things we can go monitor and look for. But then there's that kind of spot in the middle that you guys mentioned where a developer goes, hey, I could go use this tool and be 10 times more effective than I am today without recognizing that they could expose the organization to, malware. They could expose them to IP risk because of code that's brought in by the AI agent or other exposures. So with that in mind, are you guys seeing kind of this proliferation and developers kind of desiring bringing in more tools or leveraging them? And what types of governance are you starting to put in place to manage that? Because let's be honest, like it's going to happen at some point. How do we make sure we do it in the most secure way possible? And I'll start with Don, and then we can move around.
All right, sure, yeah, everybody's struggling with AI right now, right? I mean, I think everybody wants to use it and jump into it because it can do some really awesome and powerful things, but got to cut back on the reins here a little bit. I personally do not use AI at work myself. I mean, I play with it on the side at home, but we've got a whole teams dedicated to AI to figure out the best structure and the best ways to use it and incorporate it and what the advantages for it. So it's just a work in progress. I think probably everybody in this room is struggling with it, and there are a lot of people. We were talking beforehand before the meeting started tonight, and there's people out there that will give the bots any information they ask for, driver's license, bank accounts, whatever, and somehow magically they just get propagated to all the other endpoints out there, and now you've got the cat's out of the bag, and it's got to be well thought out. You just can't close your eyes and hope for the best.
So we have about 4 hours for this talk, is that right?
I was allocating another 4.
Yeah, good. Yeah, so this is it's fun seeing a new technology emerge, and it happens in waves about every 8 to 10 years, right? We see in this industry something come out that really changes things. AI does have a lot of potential. It has a lot of potential issues with it as well. I kind of look at it, I've been trying to approach it as kind of like the ISO layer model. We're experimenting with multiple potential SaaS solutions and on-prem solutions for AI-assisted coding. And in some cases, it's very fundamental things where the company comes in and says, okay, first thing you're going to have to do is publicly expose your CI/CD, like your Jenkins, and this and that, and all of your artifacts, and you're getting them. I was like, hang on a second, we just built something where it's all inside. We don't even have, there's no external presence for these tools. There's no DNS entries. Like nobody knows that we're running these things. And you're telling me that on day one to do AI, I have to undo all of those security controls that I put in place. So, there's been back and forth of trying to figure out, how do we get to a middle ground where we have a secure deployment of AI before we actually even get to the point of using the AI. The other question, and this one's been interesting, is, what are we using it for? And I don't know about, industry data, but we've seen a lot of success in refactoring code. Original code has been kind of hit or miss, and there's been some articles that have been published. For example, someone will show that I was able to code this function in 10 lines of Python, and then I ran this AI, and it did the same thing, but it wrote 100 lines to do it, right? So there's some crap that you're getting out of it. I mean, sure, it works. As someone who has to deal with product security and the SDLC, that gives me 10 times the potential surface on that code. You know, how do I test that and ensure that all of the edge cases are covered? So, you know, then you look at some of the issues around how to identify the code that was produced by AI so that I understand maybe there's an additional level of effort I need to put on that, or a different type of testing than I would on an individual. I guess the last thing I would say too is, you know, yes, there is a lot of potential. We have found some cases, for example, that, close your ears for a second, but traditional static analysis and SCA don't do, that are more grounded in the coding component of it. So for example, does your code, if you feed it, you know, the million lines you're working with, does it handle concurrency correctly? And we've actually had some successes where AI has come back in a few cases and said, you know, yeah, but if this particular thing happens, then your concurrency model breaks down. So, you know, you get into a question at that point is, yes, it was a programming issue, but, you know, as somebody who's responsible for incidents, should they occur, then it, you know, falls back in security's lap in a lot of cases to go through the root cause analysis. So it's another interesting tool to add into the toolbox, but I think that there are certain, you know, certain issues that we haven't quite worked through yet in figuring out how this AI and human interaction in this almost like a pair programming situation actually works out.
AI is everywhere. I mean, you can't go 5 minutes without hearing about some AI something. All the marketing departments everywhere have imbued AI in all the literature. Doesn't matter if it's the same product from 2 years ago. Today it is now AI enabled because marketing said so. So it's everywhere in some form. With that, we had implemented a fairly rigorous governance structure that basically put internal constraints on AI. Can't use unapproved models, can't use unapproved services, a lot of measures in place to try and build an appropriate framework to keep us, our products, our customers safe. However, developers are curious and creative folks. So within my business unit, we very quickly realized developers are going to play. So we stood up an internal large language model, our own infrastructure. So it's basically a non-connected internal AI, you know, ChatGPT-like API compatible system. So our developers who want to explore, who want to play, who want to use it, have a safe, approved internal mechanism to play with. And that has been a good balance for scratching the curiosity without encumbering all of the risk of the, you know, kind of the world out there and the thing of the day for AI. Use cases, we're very, very cautious in terms of code generation. So certainly we've got devs who are playing around with test harnesses and things that don't actually hit the production products. But from a production code standpoint, we're using our internal AI system really as an advisor, a second check, code review, almost like pair programming, except AI is the couple as opposed to code origination. And that's going to change over time as the tools mature, as we better understand the tools. But that's the more measured approach we've taken today. And, you know, from an internal perspective, that's working fairly well. However, with all the things that are at the door in terms of agentic AI and RAG and MCP and everything else, that's really beginning to, I don't know, get concerns up. Like, how do you actually keep that contained? How do you actually make that effective in terms of the guardrails? And we haven't quite figured that out. And then when you look at the headlines, especially on the agentic side, if folks were looking at OpenClaw and the headlines and Moltbook and whatnot, from a security side, you know, you look at this stuff and you go, huh, of all the problems I considered, all the things that kept me up for the past week, this was not one of them. But it is now. And that's kind of where we are in the evolution from AI governance and whatnot, is trying to figure out how do we get ahead of these things that are emerging and that are just over the not so distant horizon.
So you're saying that you did not consider that your biggest problem might be 1 million agents talking about a new agentic church?
I did not. So I'm sure that will work against me in my next raise for not having considered that. Yeah, these things are kind of crazy. Or even testing AI, right? You think about traditional applications, input validation. Hey, only accept good input. And then you look at how the large language models work, or tools like Garrick for testing these models, and it's like, okay, well, it's not like input validation of case or strings or whatnot. It's Morse code, it's Braille, and it just really expands the horizons of how you have to think about these problems, because it is kind of going beyond the bounds of the traditional computer constraints, programming constraints, and constructs that we've all kind of oriented thinking to, or at least graybeards here, if you will. So it's a new paradigm where that expression of solve puzzles to do badness, AI is perfectly capable of, and that's a new way of thinking and a new set of guardrails and tooling from the Veracodes of the world that are needed to help us with that.
Yeah, no, absolutely. I would say that we spend a lot of time actually trying to think through how to solve kind of that end-all be-all problem Mike mentioned, the logic problem. A lot of the biggest issues within software aren't security problems. They're just intent from the developer and really getting a piece of software to execute in the way you expected, with all these other constraints that are involved. And so we're constantly trying to think through that as well. And with this kind of evolution of agentic bots, whether it's OpenClaw or any other tools that kind of evolve very quickly. And I mean, that one literally went 7 days from nothing to over 1 million agents doing some really interesting things. And just on the drive over, I had an email pop up, and so they use what are basically called skills. It teaches the agent how to do things. There's now 314 documented skills that are designed to specifically go and extract through malicious intent data about the human that has installed this agent and their bank accounts, their Ethereum keys, whatever it might be. That happened in 7 days. So it's amazing how rapidly this whole issue is kind of coming upon us. So let's transition a little bit to AI. So a wonderful thing, but we have some things we have to work through. But if we get back to just traditional supply chain, SDLC, and software, when we think about hygiene and hygiene of the software we're building, hygiene of the first party, third party, open source code that we're using, like how do you and your organization think about dependency health and what things you can accept and can't accept across your organization? And start with Bill. Yeah.
Yeah, so open source hygiene is a perennial challenge, but so very, very important. So much of software today is constructed of open source code. So yes, you've got your own company's intellectual property, but what makes it work is all of these things that come from other people. And a statement I love had come from Chris Ang, Veracode, previously of, open source software ages like milk, not like a fine wine. So hygiene is necessary. You've got to keep these components current, both security-wise, quality-wise, and just aging out. There's a new version. The old thing is no longer supported. So there is so much of the software, you really need tooling, or we need tooling to help us stay on top of what's current, what the vulnerabilities are in the tools, and really work with our development teams to ensure they are paying attention to currency as well. And we get cases where we don't want to chase, as a policy, we don't want to chase the bleeding edge, but we want to stay on the leading edge of code. So a lot of packages have long-term support releases. So the churn is a little bit lower, but they keep them patched. It also helps to safeguard against vulnerabilities in brand new code, the new inspiration of the day, and really stay ahead of that, pay attention to release schedules, lifetimes of code, and try and come up with ways to migrate in a controlled manner. One of the challenges, though, that we do encounter is, since we're working with hardware, we hit hardware constraints, where the new version of code, something that is latest and greatest, just doesn't fit memory or CPU or storage and like embedded systems. So we've got to have kind of a parallel approach, too, of trying to figure out how do we address issues in these memory-constrained devices. And that goes from not updating, but really patching and trying to figure out what the fixes are to address issues. That is less desired, but sometimes necessary. And then that leads ultimately is the last part of the dependency management. If we can't update things, it's how do we end life of the products? This way we are sending a message to our customers that say, hey, this thing, we can't support it. You're aware of it, and you need to plan on the next thing for yourself to keep your environment safe, given the dependency challenges.
Yeah, totally spot on. I've seen a lot of contractual requirements that call out specific levels of the OS, like it can't be any older than one release behind the current OS or whatever. I think that's becoming more and more common, and I think the government agencies that I've seen, you go to their websites for their security requirements where they have all their NIST controls and stuff, they list that as one of the requirements that, you gotta keep updating their software, or your software, if you want them to keep using it, has to be so compliant. And sometimes the older version of software won't run like the latest version of the FIPS crypto modules that the customer is requiring, and that presents problems. So, again, you need Plan B for supply. And so, again, the contract is what's going to really save you. What happens, if you can't meet the requirements? And when you plan the contracts, like if it's a 10-year contract, you've got to factor those costs into the contract. You can't just say, here in 2026, it's going to be a $5 million contract for 10 years, because within 10 years, I guarantee there's going to be several updates to whatever it is you're designing or building, both the OS and probably maybe even your products if you're, developing software. And so you've got to plan ahead for those costs. And I think some companies don't do a good job of that, and so they're reluctant to do the upgrades, when they realize, hey, we gotta update this stuff. And I've seen where it has presented some problems at times.
Yeah, I think for a long time, we went not really even paying attention to the issue. And then we saw the landscape start to shift where if you're providing a product, your customers would start to write into contracts things like, you will not have any vulnerability graded higher than a medium or a high on the CVSS score. We started to pay attention to those things. In the last couple of years, we've started to see these requirements. It's begun moving into from compliance standard to regulations. You look at I've just spent the day going through the UK's Secure by Design. The UK and the EU are really starting to move in that direction and beginning to mandate through things like the NIS2 standard in the EU that you're coding these patterns, that you're making sure that these kinds of issues do not show up, or that you have a plan to identify and address them. We saw along the way that the whole notion of a software bill of materials pops up, which begins to help with the issue because I can begin to get tools to help me look at it. And then you get into a conundrum of, well, the day that I go from a tool that looks 1 layer deep to looks 5 or 6 layer deep, well, I discover that my code is sitting on some open source code, which has a dependency, which has a subdependency, which has a subdependency. And then I start to slowly lose my mind that, how do I replace this module, right? Is it a precompiled binary that I'm dependent on? And so I have to wait for this person to fix it and this person to incorporate their code, and then the upstream incorporates it until it eventually hits you. So it can create quite an issue. I go back to, you have to find out what your risk tolerance is, but you also have to have some kind of a contingency plan of, maybe it is time to swap this component out for something else, which is a little bit newer or has a different coding standard applied to it that's stricter. So, I think that that's going to continue to change, particularly over in the UK and the EU. We're seeing it move into the regulated space. The US backed off on that a little bit, but if you don't really start pushing in that direction now, in the next couple of years, it's going to become a serious issue. So it's worth going ahead, spending the time on looking at these kinds of things, figuring out how to implement an SBOM, but most importantly, figuring out what in the heck do I do with the results of that, because I have to have a plan to address the findings, not just hide them in a filing cabinet somewhere.
Yeah, no, I think you hit on a couple of things. So one, and just kind of talking about things we see in this space, we have organizations that are constantly looking at not just SBOM creation, but now SBOM lifecycle. How do they manage that over time? They're getting their vendors coming to them going, hey, I need to be able to share this information based on regulation, or vice versa. Your customer says, I'm not going to leverage or deploy a piece of software if you can't demonstrate an SBOM and show me what you've done within your own software ecosystem. The second piece of that, when we talked about software composition analysis and the tools we've built, and we've tried to bring some of that automated fix capability together, one of the biggest elements is I can't just look at one package and say, I need to fix that package. I might do that, but that's a breaking fix. It cascades, and the software and other elements within the software break. And so a lot of and this is a place we get to leverage AI within Veracode, is we can build the knowledge graphs of all of those, that kind of entire ecosystem of libraries that are being consumed, understand what functions are being used, and come back with a recommendation that says, hey, Mike, if you want to change this one, which you need to because of these significant risks, here's the other 10 fixes you're going to have to do for that to take action. Do you want to take it? And if so, we can help automate some of that. But that even takes a lot of orchestration of our tooling and your pipelines to make that work.
Yeah, just a question about SBOMs and what do customers come back to you with once you provide an SBOM to them? What do you hear? What do you see? What has it led to improvements in your products?
Yeah. So actually, you and I talked about this a little bit last week. Do you want to just talk to kind of publishing and managing and maintaining?
Sure. So from a customer side, a lot of the inquiries we get for SBOMs are really more regulatory. So it's, do you have one? Can you produce one? Send it to us. And it feels very much like a box check with not a lot that comes back. There have been a couple of occasions as we were starting our SBOM journey where we heard feedback from customers, given the immaturity of this space, at least at the time, to consume data. They didn't want like JSON format SBOMs. They wanted tag value, things they could search for quickly and understand what was there. So indicators that the SBOM use, certainly not everywhere, but in a lot of cases, is less mature. Improvement of product, though, now that's an interesting question. So as we went down our SBOM journey, it was discovery for ourselves, and our effort internally drove improvements in our products and our processes by generating the SBOM. So we started with open source and commercial tooling, and the SBOMs they generated were really poor quality. Syntactically correct, but the utility of them, the data, was near useless. We adopted the SPDX format, and there's a term that's called no assertion. And a lot of commercial tools populated pretty much every field with no assertion. So here's a data file that tells me nothing. But hey, I spent a lot of money to produce this and a lot of time and effort. Wasn't a winning strategy. So we really changed course where we developed internal tooling, integrated into our build pipelines to generate SBOM data from the source of truth, as close to it as we could get, the build systems. And in doing that, we gained great insights where, from a governance perspective, we thought we had bases covered, and development said, yep, we got it covered. The SBOM told a different story in certain cases. So that was very educational, and we actually had to build a set of processes that now consume the SBOMs that are developed, run a set of checks and make sure they're as we think they are, to validate the SBOMs before we go and release them to customers. And if there are issues, we drive that back in development, fix the things. And one of the drivers for this is a lot of companies in our industry are distributing SBOMs under NDAs, kind of secret squirrel stuff. Oh my God, somebody's going to know the open source code I've got in my product. We took a different approach. We publish ours publicly. And because of that high bar, we had to have a very accurate SBOM that we could stand behind and that we had confidence in the quality of it. So SBOM customer perspective, it's kind of been, okay, yeah, check the box. Right. Internal value, huge.
That's awesome. And I got here late, Bill, you're with Lenovo.
That's correct, yeah.
So Lenovo publishes SBOMs.
my business unit does, yes.
Yeah, but add to that real quick. You know, it's also another piece of data to add to all of the other vulnerability data that you're already dealing with. And so, you know, I think there's an opportunity there to consume that data, put it alongside everything else, because it'll give you a better overall picture. You know, I can really start to look and deduplicate issues or find a root cause. Well, you know, I'm getting a hit in my vulnerability scanner because this thing down here that the SBOM uncovered. I can put it into context, right? Is it something that's actually getting exposed? Because contrary to popular belief, developers don't like it when I come to them and ask them to fix something. And I don't have an unlimited number of developers and hours to do it. So I really do have to pick and choose, you know, my battles. And, you know, it's another piece of data that I can use to determine what my risk and prioritization look like, but also to be able to go to a developer and say, hey, I have a problem, but you know what? I've got like a suggested solution or two for you. And, you know, some of them will absolutely love it. Some of them have the personality of don't tell me how to do my job. But then they'll typically come back around and say, oh, actually, I discovered that that was correct.
No worries.
Got a question out there.
Oh,
Yeah, I was gonna say, thank you guys, by the way, for coming and speaking to us. I was wondering if we could backtrack a little bit. So I'm appreciating that you guys covered OpenClaw and the big issue surrounding that. So you guys are high up in your organization. I'm a student. I'm sitting here with fellow students. I'm sure there's more in the crowd. We're in a new scope of having to secure software, networks, everything like that. You guys are discussing agentic AI on the corporate scale, internal networks, everything like that. I had also 2 points to it from a security standpoint. How are you guys handling agentic AI such as ClaudeBot, which is, you know, it's marketed as open source, private, local network. I can run it at home. Nobody's gonna know what I'm doing. It's been out for 7 days, like you said. Where do we figure out what kind of vulnerabilities lie in that? Where do we set a company policy regarding agentic AI that is either A, new, or B, unsecured or unknown to a security team? And then another thing as well, I believe it was you that spoke about, you know, a hardware shortage and things like that. Obviously, I think everybody in the room can understand that there's a huge shortage of DRAM. You have Taiwan creating it and stuff like that. What happens when companies, you know, China, CXMT is now up, you know, I believe $4.6 billion because of their new NAND flashing facilities. They're expanding to Shanghai. What are we thinking of purchasing hardware and mitigating costs by using things that come from, you talk about SolarWinds too, you know, didn't know much about that. What are we thinking about using hardware that comes from countries with either A, loose security practices or relatively unknown checklist of how things like that come configured?
How much sleep do you want to lose?
Sorry, I've been dying since you talked about ClaudeBot to bring this up.
So dirty secret. I don't care about security or compliance. The only thing I care about is the company's data. So, you know, my approach, some approach is we look at the actual data as being the core of the issue, the core of the thing that I need to track and control access to, and all of these other things bolt on top of it. So, you know, if we talk about whatever they're calling ClaudeBot now, OpenClaw, I'm sure that somebody will file a cease and desist on that too in the next couple of days. But, you know, I'm really looking at it as what does that thing have access to? So, you know, at home, it's a different matter. But, you know, in like the corporate environment, you know, we have a whole process for how you get access and what level of access that you get. So, for example, you wouldn't just automatically get access to plug it into some of the databases, to plug it into S3 buckets and be able to pull data. You're going to have to, kind of, a lot of people are not happy about it, but you're going to have to ask about those things. And then we go through and look at how we track them. Because that is not a new issue, right? I mean, if you go back and look at the history of breaches, you're seeing things like, there was a mortgage company, I think, in Texas years ago that had an exposed S3 bucket. So it didn't matter if I had an open claw in the environment, then I had a problem with a data control specifically around that. So, I think to me, it's looking at it as the data and who has access to that data is the number one issue. And then I can flow a whole series of controls out from that. On the hardware piece of it, yeah. So, let's talk about supply chain for a second. The hardware is typically not being manufactured here, starting all the way down at the chip level, the IC semiconductor level. The way that it works today is you're working in Synopsys, building out your chip design. What used to be a tape out back in the day, because you literally would make a tape of here's what the IC is supposed to look like, you send it to the factory and the factory produces it, is now just a secure file transfer. And when you get that product back, typically it's fully packaged, right? You're not seeing that raw component. It's got pins on it. It's been covered over. You don't know what is really in there. So, I mean, you can lose a lot of sleep at night over things like that. We have had issues with the U.S. government buying equipment that had been backdoored. There have been issues in particular countries where equipment will be inspected. And more importantly, during that inspection, there was some value add that was done to it. And it's tough. I mean, there's a level of faith that you're going to have to put in things. But, back to, at the end of the day, there's only so much control I can put in place. You know what, and the wisdom of age, I can worry about a lot of this stuff. Like, I don't worry about a meteor hitting the planet right now. I'm going to put as much control as is commensurate to the risk. So if I've got components which are working with highly confidential or restricted data, then there's certain things that I will do there. But, at some point you just have to have that faith that, it's more so the faith that, I can control the things I can control and can't control the things that I can't control.
Yeah, so first a clarification, my hardware constraint was really not about purchasing components. It was you have a finite amount of storage or memory, and whatever you're doing exceeded that. So if you had 1 gig of RAM and suddenly you need 2 gigs of RAM, well, you've got a problem because you only have half as much as what you need. But from a hardware component, supply chain security, similar things of what we've been talking about with software apply to hardware. It's a global economy and a global market for components, but boy, are they concentrated in Southeast Asia. So in some components, you go to some of the microcircuits that are on motherboards. Those are produced exclusively in China, for example, and that's whatever you're buying. So the idea that you've got security based on geography, it just doesn't work. Instead, it's got to be a case of knowing your supply chain, trusting your suppliers, having appropriate precautions in the supply chain, a lot of trust but verify, testing, validation, making sure that you're not getting the special, as you said, value add, love that type of things. And that's just kind of a reality that needs to be considered and dealt with. There are some great technologies that are out there to help work with this. So I'll not plug the vendor, but for example, in our motherboard manufacturing, there's a technology that goes and monitors every component in the parts picking machines, basically, that build out the motherboards and does an analysis to see are there hallmarks of tampering and are all of the things on the reels. I mean, these components come in these giant reels that tape, essentially, substrate with the chip on them that gets picked and placed. Are there any variants on the reels from what they're described as being? Are all the date codes aligned? Again, tampering hallmarks. And we'll do an analysis of that to figure out, okay, here's a warning sign that there is an issue or there may be an issue. So the way to safeguard is really the companies you're working with, the suppliers you're working with, do they have mechanisms like that in place? Do they understand their supply chain? Do they know who they're working with? Or do they have contracts where they only work with a first-party supplier and not allow that supplier to outsource to another supplier to another supplier? So it's a lot of governance, due diligence, and again, trust but verify. If you're looking for an example of something that rocked the industry, I don't know, half a decade ago, look up the Supermicro spy chip scandal. And that is an interesting foray in the realm of what is somewhere between fact and fiction. It's not quite clear what that was, but it's an interesting thing that kind of brought into mind that says, okay, well, how do you prevent this and what controls should be in place from a hardware side? But again, all of the technology we use ultimately flows through Southeast Asia. Nothing's coming out of the US. And even companies that say it comes out of the US, that's really a statement on assembly, not a statement on manufacture of the components that are in the box. So this could be a whole nother panel and a whole nother day seminar on this.
Yeah. One thing I would just add to that real quick, the memory is interesting. By the way, I've got a couple of 32 gig sticks if anybody has a few $100s on you right now. That's my retirement plan.
Next giveaway.
Yeah, no. But, we've had a feast of plenty for the last 10 or 20 years, right? I could write really crappy code that works, but, all of a sudden it's like, well, why did this process, I'll pick on Slack for a second. If you've ever fired Slack up in a browser, it's like, wow, I've got a 32 gig machine and 31 gigs being used by this one tab.
And it's melting down.
Yeah, and the machine, the fan's on, the cat's next to going, man, this is too hot for even me. We've kind of have created that kind of an issue where we wind up with a problem, this consumption issue. But, to bring it back to the software development piece, I think to a certain extent we've gotten a little bit lazy in thinking that we're going to just have this continued amount of resources where, you could do more with less. I mean, you think about the transition from virtual machines to containers, right? Born out of some of those very issues. But I don't think today, outside of companies that are doing performance engineering, we haven't really pushed that down to software development. And of course, the other part of that is you get code bloat. Code bloat causes performance problems. It can cause security problems. Now you need new products in order to test these things. And then, when you suddenly are at millions and millions of lines of code, there's only so much testing you can do before you put the thing out and hope for the best.
So, yeah, I'll add a couple things. And just for clarity, like you had 22 questions in your statement. So we're trying to, we're just trying to break them all out. No, it was great. I loved it.
Sorry to everyone else.
No. So it was funny. So on the drive over here, and I'm not advocating for the podcast, but there was a podcast called All In, and they were actually talking about some of the cost dynamics, the issues with OpenCloud, and beyond the security elements, like what it would take to go and run and manage some of this. And I can't remember which one was talking about. They'd implemented it. They were using it. They were running 4 different builds across a bunch of Apple hardware, and they were hooking it back into Claude and burning about $1,000 a day in tokens. So that gets interesting. So they bring up the question of, okay, great. Like Kimi is an open source library that'll be coming out from China, right? It is incredibly fast by all calculations. You could put that on the same Mac and do the exact same models for 1,000th of the cost. And so now you're going to see some really interesting scenarios. So years ago, we went through the same process, right? Like first it's compute, and then we need more memory, and then we need faster disks to deal with the transfer of all the data, and then we want it all to be in memory, and then we need a dozen chips to be able to manage the compute. It's a constant battle. The same thing's happening with the large language providers, right? They're in a battle for who's going to create the best model. For a while there, it was all about just building the machine learning engines to create the models. Now it's about inferences, and we see, NVIDIA go make a $20 billion purchase just to get the rights to tech to do inference at 100th of the cost of what their current chips can do. The fact is, this is just, we're going to see the same thing play out. And back to, I would say the undocumented features, but the same scenario. The question they brought up was, Kimi may be the most amazing thing that's been created in the last 24 hours. What is the infrastructure we've got to go put in place if we want to leverage that? Because it doesn't matter that it came from China. It could be an amazing model, and we can put it on a M5 Mac and do incredible things and not spend $100,000 with an OpenAI or with a Anthropic. But who's going to test and validate that? And every time they release version 2 or version 3, who's going to vouch that if you go grab that model, it's secure and you can trust it and there's not some backdoor in there? The CEO of Claude made a comment like 3 days ago that was amazing. He's like, I started vibe coding with our own tools. He was like, it was incredible, but I always double checked whatever came out of it. He said 3 days ago, it has gotten to the point where it comes out so fast, I don't even look anymore. I just accept everything it gives me. Like, at what point does vibe coding just become the standard, and now we have to have a whole different set of infrastructures and approaches and policies and tools to make sure that these things aren't generating insecure code that we can't keep up with? Like, it's pretty amazing. I will one last Veracode plug, just because I think this was interesting. A year ago, we for I think 17 years now, we've built a report. It's the State of Software Security report. It's been out every year. You can go back. They're free. You can go grab them. I think they've been really powerful. Well, last year, we started a new report. It's the State of AI Security, or AI Software Security. Well, what was really interesting is when you went through the top, and I'm going to quote this and I might get it wrong, but like the top 8 models, and we did 4 specific tests, and it was like SQL injection and making sure that data was properly scrubbed and just some really basic things. Like, every model failed at some level. Now, you can do prompt injections and provided additional guidance and say, don't do this, never filter like that, never use this type of, open protocol, whatever, and get better code out of it. But the fact of the matter is, like, the worst offender was Java. Well, it was all trained on the last X number of years of work from Java. It was a huge corpus of data that was riddled with insecure code. So the AIs just learn how to write really good insecure code. And so it's getting better. Like, I'm not saying it won't get better, but this is just that same evolution, right? Like, every language, every challenge, every problem, it'll have a series of evolutions. We have to check it. We can't just go on blind faith that these things are secure and going to do what we expect them to do. So I'll just stop with that.
Yeah, that's the biggest reason why I asked the question, is because it's like rapidly evolving ecosystem, right? It's just new thing after new thing after new thing, and like you said, ClaudeBot or OpenClaude has 100 million users in 7 days.
Yeah.
So it's, especially for us, guys who are green.
Yeah.
In the industry.
It's
interesting to see.
Yeah, I would challenge everyone, and I know we're right at 8 o'clock, so I want to be aware of that. And I'm just going to make one comment, and I'll give everybody a moment to add anything they want to wrap up. I do think the foundations and the basics are super important in the security industry, right? Like, it's easy to get wrapped up in a tool that says it can just do everything for you and make it like work. But we were joking outside, like, the thing about security is it evolves all the time. I've been in this for 32, 34 plus years. My job has evolved every 18 months. I am constantly learning. I never slow down. It's tough. It is. I use the word grit. Bill said dynamic, which was a little nicer and made it feel a little better. But the fact of the matter is, it's also super exciting. But we can't give up the foundations. We have to constantly ask, is this doing what it should? Is it doing the right things? Can we trust it? And go find ways to test it. And those things will evolve. So with that.
So I guess to kind of wrap up along those lines of the future and security and inspiration and such, and it fits into software supply chain, all these things in security. Challenge assumptions be inquisitive, be interested in learning. I used to say, go and pick up a Raspberry Pi, they're cheap. Go and pick up a Raspberry Pi and, don't pay your mortgage next month with the way the prices are. But whatever the case may be, having that playground, that desire to learn and explore and figure out how this stuff works, so valuable in the security career. And that's what makes it fun, is that ability to play and learn and explore new things. So I encourage all of you, keep that curiosity alive and learn.
Yes, sir.
Yep, it's a fast and changing field. You thought it was going fast before. It's just at blinding speed now. It's only going to get faster. So I would like to thank Veracode, our sponsor this evening, and my two panelists beside me here for contributing. I think it was a great panel.
Yeah, it is exciting. I had multiple agents running today doing my work for me. Now I did trust but verify.
Called interns.
Unpaid interns who are probably now going to, sue me. But no, I think part of it is, there's definitely security aspects here when it comes to secure code development. And that's, a battle that we've been fighting for a long time. We have a long history in that. OWASP has been around for a long time because we keep seeing the same issues year over year over year. How many times can you train a developer not to code to SQL injection and then look at their next release and go, you did it again? So these tools certainly help. In looking at the other side too, the compliance aspect of it is changing. So there's a component here too that we have to address, whether it's an SBOM, whether it's a NIST2 or a DORA requirement, whatever's coming up, that we are being pushed to somehow try to certify all of these things that we're building. And there's a relationship between the two, right? Everybody always says if you start trying to be compliant, you'll never be secure. And I think that's true. I think if you start with the security aspect of it, then you have a much better shot at the compliance component of it. So whatever you're doing needs to take into account all of the security that you're trying to put into the code and into the supply chain. And I think if you're paying attention to that and risk managing, then you're going to wind up on the right side of the compliance and governance equation.
Yeah, no, that's actually, I'll leave one last thing because I do think this is important. Actually, was it Joshua? We talked briefly outside and we were talking about just different career paths. And I'll say that is one of the things for new and folks that have been doing this for 30 years like the rest of us. There are so many spaces that you can go in, find the thing that you're super passionate about, go after that. Don't go after any particular area because someone tells you to. I will say that it has evolved so much in the time I've been in it that I've been able to do some incredible jobs across a lot of different companies, both on the vendor software side, working inside of companies, GRC, pen testing. Like, security is such an amazing space. Like, don't pin yourself in. Like, you get the opportunity over this career to do a lot of different cool things. So, with that, thanks to everybody for taking an extra few minutes to hang out with us.
Thank you.